we now discuss the solution of a problem from the section Linear Algebra. The problem is on the signature of a given quadratic form. This question has appeared in CSIR National Eligibility Test held on 16th February 2022 and it is from the section B. The problem is, let V be the set consisting of A belongs to M 3 by 3 over R, where R is the set of real numbers, such that the transpose of A plus A belongs to R dot I, where I is the identity matrix. Consider the quadratic form defined as Q of A is equal to square of trace of A minus trace of A square. What is the signature of this quadratic form? We are given four options. Option 1, plus, 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 plus. Option 2, plus, 0, 0, 0. Option 3, plus, negative, negative, negative. Option 4, minus, minus, minus 0. So we are given V is the set of all those matrices coming from the vector space of 3 by 3 real matrices, such that the transpose of A plus A belongs to Ri, where I is the identity matrix, and you are given a quadratic form defined as Q of A is equal to square of trace of A minus trace of A square. And we have to find the signature of this quadratic form. These four options are given to us. Read Q of A as trace of A square minus trace of A square as trace of A whole square. This is to be read as trace of A whole square and minus trace of A square. This is for our clarity, we have taken like this. Now we discuss the solution of the problem in detail. Given V is the set of all those matrices coming from M 3 by 3 over R, that is the vector space of all 3 by 3 matrices with real entries, such that the transpose of A plus A belongs to R dot I, where I is the identity matrix. Here R dot I means alpha I, alpha varies on real numbers. That means it is the 3 by 3 matrix alpha 0 0, 0 alpha 0, 0 0 alpha, alpha belongs to R. That means R dot I consists of all scalar matrices, 3 by 3 scalar matrices with real entries. Let us take an arbitrarily chosen matrix capital A as A, B, C first row, second row D, E, F, G, H, I the third row. Now A transpose is, you take this, write its transpose. The transpose of this is this: A, D, G, B, E, H, C, F, I plus A, the matrix, arbitrarily chosen matrix, A, B, C, D, E, F, G, H, I, and that is equal to, that belongs to R dot I, means that will be a scalar matrix of this type, alpha 0 0, 0 alpha 0, 0 0 alpha for some alpha. As A's and A, these things A, B, C, D, E, F, G, H, I are varying, and alpha also varies according to this. For a given set, given A, B, C, D, E, F, G, H, I, this is sum alpha what we have. Now add, addition we know, add component wise, that is a plus a 2a, d plus b, g plus c, like that we have added, and that is equal to the scalar matrix alpha 0 0 0 alpha 0 0 0 alpha. Now two matrices are equal if and only if their corresponding entries are equal. Let's do it in the next slide. And this is what the addition, and this is a scalar matrix. So this will imply 2a is equal to alpha, d plus b is equal to 0, g plus c is equal to 0. That is first equating the entries of the first row. Second row, b plus d is equal to 0, 2e is equal to alpha, h plus f is equal to 0. Third row, c plus g is equal to 0, f plus h is equal to 0, 2i is equal to alpha. And 2a is equal to alpha means a is equal to alpha by 2. And the second one, b is equal to minus d, or d is equal to minus b, and g is equal to minus c. G is equal to minus c. And b plus d is equal to 0 we have already considered. And 2e is equal to alpha, e is equal to alpha by 2. H plus f is equal to 0 means h is equal to minus f. And c plus g we have already considered, f plus h we have already considered, and 2i is equal to alpha. This will imply I is equal to alpha by 2. And therefore the matrix A is equal to A alpha by 2, B, C, D is minus B, E alpha by 2, and accordingly we have kept these things, right? So we got capital A, the matrix. Let's continue in the next slide. We have this matrix, agreed, and the given quadratic form is Q of A is equal to trace of A whole square minus trace of A square. And the trace of A is known. The trace of A is the sum of the diagonal entries alpha by 2 plus alpha by 2 plus alpha by 2, that is 3 alpha by 2. Yes. And to get the trace of A square, first of all let us compute A square, A into A. Now what we want is the trace of A square after multiplication. What is the sum of the diagonal entries? So therefore we just compute the diagonal entries only. So the first is first row, first column, that is 1 element, and a 2 element is second row, second column, and 3 element is third row and third column. Multiply. So if you multiply alpha by 2 whole square minus b square minus c square, first row, first column, multiply by first row, first column, second row, second column, third row, third column. So multiply, if you multiply you will get these entries. Agreed. Now let us continue in the next slide. And trace of A we have already seen, 3 alpha by 2, A square we have already seen, these are the diagonal entries. Therefore trace of A square is equal to the sum of the diagonal entries, this plus this plus this. So, and this is equal to 3 into alpha by 2 whole square minus b square minus 2b square minus c square minus c square minus 2c square minus f square minus 2f square. So this is your trace of A square. Now Q of A is equal to the square of trace of A minus trace of A square, that is equal to 3 alpha by 2 whole square minus the trace of A square is this one. Now simplify. So this minus this will be 3 by 2 alpha square plus 2b square plus 2c square plus 2f square. So that is the Q of A, the quadratic form of A. That's how we got. Yes. Now this so X transpose the matrix 3 by 2, 0, 0, 0, 0, 2, 0, 0, 0, 0, 2, 0, 0, 0, 2, x, where x is the column vector alpha, B, C, F, alpha, B, C, F. This is the quadratic form. This is the quadratic form. This quadratic form is already in the canonical form. So note that alpha, B, C, F are the real variables, therefore it's a real vector. Q of A is already in the canonical form. Is already in the canonical form. Now rank of Q of A, R is equal to rank of Q of A is equal to the number of non-zero entries on the main diagonal in the canonical form, that is 4. K, the index of the quadratic form. A is the number of positive terms in the canonical form. They are all positive, therefore 4. And the signature of Q of A is the number of positive terms minus number of negative terms. There are no negative terms. The answer is 4. The signature is 4 means they are all positive. Therefore, it is given as signature of Q of A is plus, 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 plus. So that is a positive definite quadratic form. So we have the 4 options. In that our answer plus, plus, plus now appears again as the option 1. Therefore, our answer is option 1. So that is the discussion of the solution of the problem from the linear algebra, and it is about the signature of the given quadratic form. I am sure that you have understood the solution of this problem, and the questions on quadratic form are very frequently appearing in this national eligibility test. So concentrate more on this, and they will be normally be very, very easy to answer. I wish you all the best. Thank you.